So this video is going to show you how to find geometric probability given a shape, and we have to determine the probability of landing in the shaded region versus the probability of landing in the unshaded region. And we're going to list our answers as percents. So some questions are like this, where you don't have to apply any formula whatsoever. You can just use proportions. And we can see that the shaded region, that there's 4 sectors of the shaded region, and there's equally as many unshaded. So 4/8 is shaded, and 4/8 is unshaded. So we can just divide those and determine the percent, and you should probably immediately see that this is going to be 50%. But if you needed a reminder, you do 4 divided by 8 is 0.5, multiply that by 100, and you get the percent, 50%. So most of the questions on here on this assignment are not like this. Instead, you're going to be using formulas. So you're going to have to remember some of your area formulas. So let's look at problem 2. So problem 2 is a rectangle and another rectangle inside it. So I think it's going to be easiest to find the unshaded probability first. Okay. So first, you need to determine what is the area of a rectangle, if you recall, is length times width. All right. So let's do the unshaded probability first. So unshaded, the area of this rectangle is going to be 3 times 9. And remember, you have to do it over the total. So the total is 9 times 15. So if I take out my calculator, 3 times 9 is 27. And then 9 times 15 is 135. Okay, so that's the fraction of unshaded. The 27 is the unshaded over the total shape, 9 times 15. So if I divide these, I'll change it to a decimal. 27 divided by 135 is 0.2. If I multiply that by 100, changes it to a percent, 20%. So if the unshaded is 20%, the shaded region must be the remaining percent, or its complement. So if the unshaded is 20%, the remaining percent would be 80%, must be shaded. And the way I got that was I did 100%, which would be the whole thing minus the unshaded. Okay, I'm going to do 2 more. One with a triangle and one with a circle. All right, and then you will be in charge of doing the rest. All right, so this problem we're going to do similarly. Remember that the area of a triangle is half of a rectangle, so it's length times width, but then you have to divide by 2, right? So for the unshaded, so these meet at a right angle. So for that triangle area, so we're going to do unshaded first. So first the triangle, which is the numerator. I'm going to do 10 times 24, but then I have to divide by 2. So that's the unshaded area. And then that's the triangle. Then I have to divide by the entire rectangle's area, which would be 30 times 20. So let's make a fraction. So I do 10 times 24, enter, divide that by 2. So that's the numerator. That's the area of the triangle. And then 30 times 20, I could do that without a calculator. That's 600. So let's convert this fraction into a percent. So we know what percent of this shape is the triangle. So 120 divided by 600, 0.2 again, times 100, 20%. So similarly, the shaded area of this one also, like the previous problem, is 80%. All right. I'm going to do one with a circle. I might do this one. Let's see if there's a different one I should do. I'll do problem 11 on the next page. So for these, you're going to have to do area of a circle formula, which if you recall is pi r squared. So pi r squared, that's how you find the area of the circle. Remember that pi is halfway across. So again, we're going to start with the unshaded on this one. So the first step is, well, what's the area, or excuse me, what's the radius of these circles? So these two circles are the same size. We can kind of see that. This goes all the way across of 4. So that means that these each must be 2 across. This is 2 across and that's 2 across, which means that this is a length of 1. So let's find the area of this circle and add it to the area of that circle, and then we have the unshaded area. So pi 1 squared is the area of that circle. And since they're both the same size, I can just multiply this by 2. That's going to be the area of the two circles together. I have 2 circles of pi 1 squared. And then I'm going to divide that by the total area of 3 times 4. So if I multiply this out, 2 and the pi button on this calculator is over here, which is, you could just use 3.14 times 1 squared. That's going to be the numerator. So 6.283 divided by 3 times 4. So if I take my numerator and divide it by 12, the denominator, it changes it to a decimal. Then if I multiply that by 100, change it to a percent. So the unshaded area is 52.36, or if I round it up, let's just do 1 decimal, so 52.4%. And then to find the shaded, I just have to subtract it from 100. So 100% minus 52.4 is going to be 47.6%. Okay, so that's how you do this problem. So the expectation is that you would complete the rest of these problems using the 3 formulas you need are area of a circle, area of a triangle, and area of a rectangle. All of these you're going to use formulas except for the last one. The last one is similar to problem 1, where you're just going to look at the fraction of the total. And so what I would suggest when you do 15 is to divide this into little itty bitty triangles. Count them all up. Okay, you can divide the whole thing into itty bitty triangles like that. And then just make fractions.